So last time we began talking about section 3.2. We were looking at our graphs of quadratic functions. We did a couple review problems of graphing, and then we came to the situation where, okay, if I have a quadratic function that's not in the vertex form and I want to graph it, what do? And so we talked about this process called completing the square. We just barely got through the one problem, so we're gonna lead off by practicing it. So the completing the square said we grouped the terms with the x's. So in this case, it was the x squared and the 6x. I told you to skip step 2. We'll talk about that today in the course of our other examples. And then the completing the square means to take half of this term in the middle, the 6. So half of 6 was 3. 3 squared is 9. We added the 9 inside the parentheses. To keep the function in balance, I then subtracted 9 because 9 minus 9 is 0. By factoring from intermediate algebra, we see the two factors of 9 that add up to 6 are 3 and 3. So that allowed me to factor that trinomial into x plus 3 times x plus 3, or in other words, x plus 3 squared. And so my equation of my parabola is x plus 3 squared minus 4. Now from this, we are able to figure out what the shift is, what the vertex is. So what's happening with this parabola? Where am I going to go to graph this? I'm sorry, what'd you say? Yeah, I'm going to go left 3 down 4. Okay, we've talked about that. Left 3 down 4, that's not the new part. And so I'm going to take my parabola left 3 down 4. I'm going to make my vertex here. And so I go over 1, up 1, back 1, up 1, and then up 4. And then I can go up 9. And here's my lovely parabola. So we can label the vertex, which was something we'll start doing. That's one of the things that we will be talking about as far as going through this section. So the vertex of this, I'm going to use V for vertex. Since I went left 3, the vertex x value is -3, and down 4, the y value is -4. And there's my vertex. There's some other things that we will pardon me, that we'll talk about as far as this, but here's what I'd like you to do. Before we do exercise 3, and we go through and we do the graphing and everything, I just want to make sure that we have covered the completing the square. So here's a problem. Just flip over to the back of your page or a fresh sheet of notebook paper. Sorry, excuse me. I would like you to please complete the square on this problem and write it in the vertex form. So this one is f of x is equal to x squared minus 10x plus 27. So go ahead and complete the square, write that in the vertex form, and then just tell me what the vertex is. You don't have to graph that one. Just tell me what the vertex is. Okay, so step 1, I'm just going to follow along with the steps that I wrote out for you last time. The first step is we're going to group the terms with the x's. So I'm going to say, okay, I'm going to put the x squared minus the 10x in parentheses grouped together. I'm going to leave a little space, and I'm going to put the plus 27 on the outside. We don't have a second step here. We'll talk about that in a few minutes. Now I'm going to actually do the completing the square step. And what completing the square is, again, just repeating, so hopefully it clarifies. I want to add a number in here in the parentheses that makes this trinomial a perfect square. That's why it's called completing the square. I'm going to complete the trinomial to make a perfect square. What number am I going to add here?
25.
Where'd you get the 25 from?
Multiply -10 by 1/2, and then
Perfect. Half of this number right here, and you can consider the negative or not. We're going to square it, so it's going to be positive. What's half of -10? It is -5. What's -5 squared? Plus 25. So I'm going to add 25 inside there. Okay, that's the key to the step. If you have a question, ask it. I've got to keep my function in balance. I have just added 25. I have changed the function. So what do I do out here to keep my function in balance? I'm going to subtract 25 because now 25 minus 25 is 0. Okay, so I've not changed anything. So now the x squared minus 10x plus 25, you don't have to write this step. I just find students like this when they're first learning. X squared minus 10x plus 25 is x minus 5 times x minus 5. 27 plus 25 is plus 2. And then maybe some of you just skipped right to this step, and we've got x minus 5 squared plus 2. So what's the vertex? How far or what direction in the x direction have I gone? Gone right 5, positive 5. And then how far in the y direction have I gone? Up 2. There you go. So where does the vertex come from? It just comes from the transformation that we've dealt with before. All right, well, that was just quick review because this is, I'm pretty sure for a lot of you, this is a new skill. So I just want to make sure we're covering it adequately. So what I would like you to do next, please, is exercise 3. Go through the whole thing. I'd like you to complete the square on the exercise 3 problem, identify what the vertex is, and then sketch the graph. Yeah. Of course. Have 2 if you want. All right, so on this problem right here, I'm going to group the x's. So the x squared minus 8x are now in parentheses. I'm going to leave a little space, and then I'm going to put the plus 10. It's outside. So here's the completing the square step. What am I going to add inside here to make this trinomial a perfect square? 16. Half of this term, half of the middle term is 4. 4 squared is 16. And so then after that, I'm hoping that you subtracted 16 outside. That's the key step. Anybody got a question? Anything you're not quite visualizing here? I'm sorry? Okay. Well, we want to take this polynomial function here. We want to write it in a format that we can graph it right here. So we want to be able to find the translation. And so what we're doing is we're doing the completing the square. This is from last class, so hopefully you watched the video. This is the completing the square step. You group the x terms together. And then there's a second step we're going to do in just a minute when we turn the page. Completing the square says take half the number in front of the x. Okay, on the example we did in class last time, that number was 6. Half of 6 was 3. Then we square the result and we get 9. And then we balance the function. So right here, when we go through and we do our completing the square, we grouped the x's, the x squared minus 8x. I put the 10 outside the parentheses. I took half the number in front of the x, which is 8. Half of 8 is 4. 4 squared is 16. And now I keep the function in balance. I added 16 here. I subtract 16 out here. So 16 minus 16 is 0. And what we've done now is x squared minus 8x plus 16. The two factors of 16 that add up to -8 are -4 and -4. We've got a perfect square. And then outside here, 10 minus 16 is -6. So now that's a perfect square. So we've got x minus 4 squared and then -6. So what's the shift? What do I do with this graph to get to its new destination? Right 4 and then down 6. So that means my vertex, when I go right 4, that is the positive x direction. So 4, and then down 6 is the negative y direction, so -6. So I'm going to take the whole graph, right 4 and down 6. So here goes. Right 4 and down 6 is where my vertex is going to be. And then if you have to draw the basic graph, that is fine. You can sketch that in a little bit lighter or draw it dotted, whatever you need to do. And I'm just going to go ahead and complete this graph. Oops, wrong place. There it is right there. And here's my parabola. My vertex is at 4 and -6. All right, we're going to try again, but this time I'm going to add in that missing second step that I've been very elusive about. So flipping to page 2, notice when we go to do the problem on page 2, what's the difference in this problem that we notice versus the other 3 problems that we've completed the square on? Number in front of the x squared. So I have to understand how to deal with this. Okay, so I've got 2x squared plus 4x minus 7. So here's my completing the square steps that we wrote down last time when we did the first problem. So we're going to follow along. Step number 1, let's group the terms with the x's. Okay, I can do that. So I've got 2x squared plus 4x. I'm going to leave a little gap. I'm going to put the -7 outside. Now this is super important. Before I can complete the square, I have to do one other thing on this problem. This didn't come up because we had a 1 in front of the x squared on the other ones, because that's the simpler situation. Simple is not easy. It's just simpler. It was less steps. So what we have to do now, this second step, is you factor out the coefficient in front of x. Oh, I'm sorry, in front of the x squared. You factor out the coefficient in front of the x squared. In order for completing the square to work, you have to have a 1 in front of the x squared. Otherwise, it's just a multiplication nightmare. So on this problem, what that means is this 2 that I have right here in front of the x squared, I'm going to factor it out. So I'm going to write my equal sign. I'm going to factor that 2 out of my parentheses. The 7, I don't care. It's outside the parentheses. So I'm just going to write the -7 outside. 2x squared, when I factor out the 2, this is a little introductory algebra for you. What's left? 1x squared, great, or just x squared. 4x, when I factor out the 2, what's left? Plus 2x. Okay, we're ready to complete the square. I'm just going to pause and give everybody a chance to catch up with me because I want to make sure that we're straight on these next 2 steps. Okay, step 3 is the completing the square step. I have to know what number am I going to add right here in order to complete the square. What is that number? 1. Half of 2 is 1. 1 squared is 1. Everybody tracking where that 1 came from? Anyone who's not tracking where that 1 came from? Okay, now this is the part just to pay attention to. We've got to keep this in balance. So if you already threw down a -1 out here, I appreciate the effort, but that's not quite right because we have to take into account that we factored out this 2 in front of the parentheses. So I've added 1 in here, right? We did that. You all said that you see where that 1 came from, so I'm trusting you. But what have I really added to the problem if I was to redistribute? I've really added what to the problem? I've really added 2 because I'm just going to try to draw this without making too much of a mess. 2 times 1 would be 2 if I redistributed. So what would you say then I have to subtract out here to keep this in balance? Okay, 2. So be careful in keeping it in balance. That is the most common mistake. Students tend to, on tests, do really good on this completing the square when there's a 1 in front of the x squared, but sometimes get tripped up about keeping the equation or keeping the function in balance when there's a number in front of the x squared. So just to recap, I'll get to your question in just a second. Just to recap, I factored out this 2 in front of the x squared so that I could complete the square. Okay, now it's outside the parentheses. I did the completing the square step just like I did on the other 3 problems. I took half of 2 is 1, and when I square it, 1 squared is 1, and that's why I put that +1 right there in red. But then what I have to do before I keep the equation in balance is remember that I have this 2 out here in front of the parentheses. So if I redistributed, 2 times x squared is 2x squared, 2 times 2x is 4x, 2 times 1 is 2. So to keep it in balance, I subtract 2. Okay, now the rest of this. I've got my 2, x squared plus 2x plus 1. The 2 factors of 1 that add up to 2 are 1 and 1. So I've got x plus 1 squared. And then -7 minus 2 is -9. So now when I go to graph this problem, 3 things are happening on this one. Tell me one of the things, please. We're going to go left 1. That's one of the things. Great. Left 1. What else is going on with this graph? Okay, it's going down 9. We got those 2 out of the way. What's the other thing that's happening to this graph? Perfection. We're going to multiply the y's by 2. Again, depending on where you are on the curve of graphing things, I understand we learn at different rates. Some of you have done more practice than others. If you need to draw the basic graph real quick, I'll do that right here. These are my basic points that I have that I've been doing over and over since we started talking about functions. I'm just going to do this as a little dotted line. Okay, first thing I'm going to do, I'll do it in black ink just to distinguish it from my pencil. First thing is I'm going to multiply the y values by 2. So this y value is 1. 2 times 1 is 2. So I'll just dot that in. This y value is 4. 4 times 2 is 8. So I'm going to go up 8. The next one is 9. 9 times 2 is 18. That's too big for my graph, so I don't need it. Or I need it, but I'm not going to graph it on my little graph here. So in black, that is 2 times x squared. And now I have to do the shift. So I know you might not be as fast at this as I am, but I'm hoping none of this is mysterious because this is the topic of the previous test right here that you did a whole bunch of. So now I'm going to take this left 1 and down 9. So left 1 down 9 is right here. I'll do this point left 1 and down 9. This point left 1 down 9. And then this one right here, left 1 and then down 9 takes me to -1. And then left 1 down 9 to -1. And here is my graph. Before we move on to the next one, you're going to practice again. What's the vertex of this graph right here? -1, -9. Great. The left 1 means the vertex is -1. Down 9 means that I go down 9, -9. Okay, the vertex I just get from the shifting that I do to my graph. Okay, same thing, exercise 5. It's the same exact thing we've just done now on that previous problem. Here are the steps, in case you don't have them in your notes. Go for it. get started, check your work with my work. If you have any questions, please let me know. So here we go. I'm going to group my x's. So I've got my 3x squared plus my 12x. I'm going to put the plus 6 outside the parentheses. Step 1. Step 2, since I have a number in front of the x squared, I'm going to factor out the coefficient in front of the x squared, which is a 3. So I've got 3 times x squared plus 4x. Again, I'm leaving that space. I don't worry about factoring anything out of the 6 because it is outside the parentheses. So far, we so good. Everybody with me? Okay, next thing to do then is I am going to go ahead and complete the square. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 inside the parentheses. That completes the square. Who can tell me what am I going to now do outside the parentheses to keep this in balance? Subtract 12, yes, because if I redistribute 3 times 4, what's 3 times 4? It is? Yes, thank you for the 4 of you that responded. 3 times 4 is 12, and so then I'm going to subtract 12. Okay? That 12 comes from the distributing. So now when I'm done completing the square, I've got 3x squared plus 4x plus 4. The two factors of 4 that add up to 4 are plus 2 and plus 2. So this is x plus 2 squared. And 6 minus 2 is, or excuse me, 6 minus 12, even better, is negative 6. So once again, 3 things are happening on this graph when I go ahead and graph it. I'm going to give you the, it's going to go left 2. We're going to go down 6. What's the other thing that's happening on this graph? We're going to multiply the y's by 3. Again, if you needed to put in pencil your basic graph, that's fine. I'm going to skip right to the multiplying the y's by 3. My first y tends to be 1, so now it's going to be 3. My second y value is 4, so now it's going to be 12. So I'm going to have to guesstimate a little bit just so I have enough points to draw a great graph. So here is my basic graph stretched out by a factor of 3. And now I'm going to take that graph and I'm going to move it left 2 and down 6. So left 2, down 6 puts that point right there. And then here are my 3s and then my 12s. So we're down 6. So we're going to be up here at positive 6. The vertex, since we went left 2, that's negative 2. Since we went down 6, that's negative 6. All right, one more that you're going to do the full thing for me. So exercise 6, be careful of that negative. Okay. I know you can do it, though. All right, I'm just going to get started. Check your work with my work. Ask whatever questions you need to ask me. So I'm going to first group my x's. So I have negative 2x squared plus 12x. I'm going to put some parentheses around that. Put the minus 13 outside. Again, I've got a number in front of the x squared, so I'm going to factor out that coefficient. This time, what makes this problem a little different, and the reason I'm asking it, is we've got a negative. So it's a negative 2 that I'm factoring out. So this will test your ability to factor. So when I factor a negative 2 from the negative 2x squared, I've just got x squared. I don't think that was the challenge. What do I have left when I factor the negative 2 out of the 12x? Okay, negative 6x. Remember, you can always check your factoring by redistributing. So negative 2 times negative 6 is plus 12. Okay, quick check. Now I'm going to do the completing the square step. What am I going to add right here in the parentheses that completes the square? Half of 6 is 3. 3 squared is 9. I hear one voice. Do I have other voices? Are we getting this? Because I can do this. I'm great at this. I want to make sure that you can. If that's why we did an extra example today that wasn't on the page. I just want to make sure that we're doing enough. Okay, so we add 9 in there. Okay, now when I take into account, this is where to, again, be careful of this sign. I get it. This is tricky. That's why I'll caution you. What have I done to this problem when I added the 9? I'm sorry, what'd you say? Yeah, what do I get when I multiply these two things right here? Negative 18. So how do I balance this function if this is a negative 18? Okay, I'm going to add 18. So if you subtracted 18 out here, I get it. I totally understand. It's tough when you go through this first time. But the reason it's adding 18 is because of this negative that is out in front. So be real careful of that. Signs can sometimes be goofy on us. I totally get that. Okay, I am so not observant sometimes, so I have to be real careful. So then the last thing here is I've got my negative 2. The two factors of 9 that add up to negative 6 are x minus 3 and x minus 3. Negative 13 plus 18 is plus 5. So again, 3 things are happening on this graph. We're moving it right 3. We're moving it up 5, and then we're multiplying the y's by negative 2. Again, if you've got to draw your basic parabola and pencil, that is fine. Okay, do that. I have, if you remind me next sometime, I have color pencils in my office. I just always forget to bring them because I'm not observant. And so I'm going to multiply my y values by negative 2. So negative 2, instead of 4, I have negative 8. Instead of 9, I'd have negative 18, but that's going to be off my graph, so I'm not gonna worry about it. So here's my parabola stretched out and reflected by a factor of negative 2. And now I'm going to take that and I'm going to move it all right 3 and up 5. So right 3, up 5, that moves my vertex right there. And then my y values that are negative 2 are going to look like this. And here is my final graph in beautiful red. The vertex, since I went right 3, is at the x value 3, and I went up 5, so the y value is 5. And there we go. Okay, so we have one more thing from this section, but before we do that, we're going to go back to a couple of these graphs, and we're going to identify some other key elements as we're getting to know our parabolas. So exercise 7 says, for each of these things, we're going to state the vertex. We've already stated the vertex. We've been doing that as we go along. That just comes from my translation. But there's some other things we're going to look at. We're going to look at what the line of symmetry is. Now you might be saying, well, what in the world is that? If you remember in chapter 2, when we talked about even and odd functions, we discovered that the parabola, the x squared, was symmetric about the y-axis. But now when I'm moving stuff around, like you can see here, no longer are these graphs symmetric about the y-axis. They have a different line that I can fold it and it'll be the same. We're going to identify what that is. We're going to identify whether the graph has a maximum or a minimum, because that's one of the places where parabolas become very useful, is in modeling and determining maximums and minimums of different things. And then I think, and then the domain and the range. So I'm going to flip back to the front page. I'm going to look at my example 1. So example 1, when I ask you what the line of symmetry is, I just want to know what line, what vertical line would I use to fold this, that it would be the same. So notice I've moved this graph. We said back at the time we moved this graph left 3. So that means I've moved the whole thing, including the line of symmetry. I'm just going to make a dotted black line here so you can see. I've moved my line of symmetry left 3. I could fold that graph along that line, whatever the equation is, and it's the same on both sides. So the line of symmetry, which I am very cleverly going to abbreviate as the LOS is the line x equals -3. The line of symmetry is just however far left or right you moved your graph, that now becomes your line that it's symmetric about. It's the same on both sides. Before we do the domain and the range, this graph right here, the parabola is pointing up. You can see the arms of the parabola are reaching to the sky. So do you think that this parabola, if I was looking at it, has a maximum value or a minimum value? Okay, so I understand why first time I ever asked this question, you say maximum, but the problem is this never stops going upward. So it doesn't have a maximum because you can always find something bigger. Okay, so there's no maximum on this because this keeps going up, 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 up forever. But it does drop down to a minimum value. Okay, so when the parabola is pointing up like this one, arms in the sky, this one has a minimum value. And that minimum value is whatever the y value is. When you're asked for a minimum or a maximum value, it's the y value. And so in this case, that was -4. And then domain and range, I don't think the domain and range are too much of a mystery. We've done them before many times. The domain of this, left and right, well, this goes from -infinity to +infinity. All of my parabolas do. And then my range, my lowest y value, we just saw the minimum was -4. And then the maximum y value, the upper limit, there is none, so we use infinity. And that's the range of this graph right there. So also on the screen, you can see exercise 3. So if you do the same thing, underneath the vertex, what's the line of symmetry? Does it have a minimum or a maximum value? And then what's the domain and the range? Okay, what line is going to be the line of symmetry for this graph right here? Okay, yeah, please, I heard you say 4, and that is exactly right. I know what you mean, but please write x equal to 4 because y equal to 4 would be a different line. So just want to make sure that you're understanding it's that vertical line that cuts right through the center of the parabola. Does this one have a maximum or a minimum value? Has a minimum, and what is the minimum? Perfect, thank you very much. And then last but not least, the domain and the range. The domain is boring, it's -infinity to infinity. The range of this one, because it has a minimum value, the lower bound is -6, the upper bound is infinity, and there's that. I'm just going to have us do this for one more of the problems that we've gone through, and then there's one more little thing from this section, and then we'll be done with section 2 of this unit. So if you would, for exercise 6, this red graph that's pointing downward. So for this graph right here that we're looking at, what is the line of symmetry of this one right here? Okay, x equal to 3. Again, make sure you're telling me the x so that I know that it's the vertical line. And then does this one have a maximum or a minimum? This one has a maximum because it's pointing downward. So it has no minimum because those arms of the parabola are going to keep going down forever and ever. So there's no place where it stops that we could call the minimum value. So this one has a maximum, and that maximum value is 5. And then the domain and the range, again, the domain, boring, negative infinity to infinity. The range, a little more exciting, is negative infinity because it doesn't stop going downward, all the way to 5 as the maximum value. All right, there's a lot there, and I know completing the square, I know it's a tough thing, but please practice, do your homework. There's one other thing. There are certain situations where you might not be interested in the graph because the vertex tells you a lot of information about a parabola. So you might just want the vertex. And if the vertex is like a decimal or if it's a fraction and it's not going to be good to graph anyway, then you want a way to be able to figure out quickly in some situations what the vertex is. So there is a formula that we can use if we just want to know what the vertex is. So it goes like this. The vertex of any parabola always abides by the following. In fact, it's the x-coordinate of the vertex. The y-coordinate you just get by plugging this value in, but the x value is negative b over 2a. And in case you've forgotten, because I know it's been a while, or maybe you've never known, in our standard form of a parabola, a is always the number in front of the x squared, b is always the number in front of the x, c is always the number that's added on to the outside. So the vertex goes by this form, negative b over 2a. Now this second part, the y value, this is going to look complicated, but when we do a problem, it's not going to be super complicated. What I'm just going to say is I'm going to plug that into my parabola. So I'm plugging into my parabola, my p, that's what the notation up here is, and I'm plugging negative b over 2a in as the x value. So that's just my function notation. I know it looks goofy, it looks like there's a lot going on there, but when we do a problem, it'll really appear much simpler than that. All right, so I'm going to do example 3. And then I've got exercise for you, and then we'll be done with this section unless there's any sort of issue that anybody has. So here we go. I'm going to use the vertex formula to find the vertex of this function. Then real quick, we're just going to look at the attributes of it to determine does it have a minimum or maximum value, and we'll determine what to look for. So here we go. I'm going to figure out what negative b over 2a is. That's the x value of my vertex. So according to what I have, what's the value of b of this parabola? -4. So I've got -4. The first negative is part of the formula, the negative b over 2a. This second negative, that's the value of b, is -4. What's the value of a of this parabola? 2. So in the bottom, I have 2 times 2. Again, the first 2 is the formula, 2 times a. The second 2 is actually the value of a. So here we go. In the top, negative times negative is +4. In the bottom, 2 times 2 is 4. And so I get that the x-coordinate of the vertex is 1. The y-coordinate of the vertex, I'm going to use some of this white space down here because I didn't really leave myself enough room. Sorry about that. What I'm going to do is I'm going to take this x value of 1 and I'm just going to plug it into the function. So what is the function value at 1? Well, it is 2 times 1 squared minus 4 times 1 plus 5, just a little plugging and chugging. So that's 2 minus 4 plus 5. That's equal to 3. So my vertex, the x-coordinate of the vertex is 1. That we got that from the negative b over 2a. The y-coordinate is 3. We got that just from plugging back in. And that's the vertex. Good. We got it. So one more time, does this one, looking at this parabola, maybe you know what to look for. Is this one pointing up or down? Meaning, does it have a maximum or a minimum value? How do you know it's pointing up? That's a great observation. Okay, so if we think back to our graphs that we just did on page 2, okay, when this number in front of the x squared that when we factored it out and we multiplied all the y values by it, when it's positive, that means the parabola, the arms are in the sky. It means it has a minimum value. If this number in front of the x squared was negative, that would mean it's pointing downward. We reflected it, so it would have a maximum value. So this one right here has a minimum value, and that minimum value, it's just the y value of the vertex. It's just a minimum of 3. All right, last problem for this section. I'm going to give you a couple minutes. Go ahead and do the same thing for exercise 8. It's going to turn out to be a fraction. You're welcome to use a fraction or a decimal when you get that. I do not really care which one you use. So my vertex, the x-coordinate of the vertex abides by the negative b over 2a. So for this particular problem, what's the value of b of this one? Perfect. So it's -6. Again, this negative, the first one is from the formula. The second negative is the value of b. In the denominator, it's 2 times a. So 2 times what? Perfect. Great job. So in the top, I have 6. In the bottom, I have -4. So that becomes -3 over 2. Or if you used decimal, -1.5. Doesn't matter either way. And then I'm going to plug that value into my function. So my function at -1.5 or -3/2 is going to look something like this. I've got -2 times -3/2 squared minus 6 times -3/2 minus 5. I know fractions are awkward. You've got calculators for decimals. I figured 1/2 or halves are not the worst fractions to have to work with. So -3/2 squared, that's 9 over 4. So I have -2 times 9 over 4, or if you're using decimals, that's 2.25. And then -6 times -3/2 is going to be plus 2 goes into 6 3 times, and 3 times 3 is 9. Here, this 2 is going to go into the 4 twice, so I have -9 over 2 or -4.5 if you're in decimal land. And then when you add all that together, this is -4.5 plus 9. That's going to give me +5.5, and then -5 is going to give me +1/2. Or no, did I do that wrong? Yes, it's -0.5. Pardon me. Let me do that again. 9 minus 5 is 4. This is -4.5 or -4.5. So -4.5 plus 4 is -1/2. Sorry for my sloppy math. So the x value is -3/2. The y value is -1/2. This particular problem right here, does this one have a maximum or a minimum value? Why are you saying maximum on this one? Because it's pointing where? Pointing down. The arms are going downward. I know that because of the negative in front of the 2. Okay, so this one's pointing downward, so it has a maximum value, and that maximum value is -1/2. Yeah.
So you said we could use decimal point?
Yes. So if you use decimal, you got -1.5 and you got -0.5 are your decimal answers there. Anything else before I move on?